I am Dr. Himanshu Sarkar. Welcome to all viewers in my YouTube channel. In my last class, that's the conduction unit, I had given some of the lecture notes. In my previous lectures, I discussed what is called thermal conductivity, what is the dimension of thermal conductivity, what is the thermal resistance, what is the series equivalent of the conductivity, what is the parallel equivalence of conductivity, etc. Now, I will discuss. Already you have noticed that ice formation over lake in very cold countries, you have noticed. And very interesting is that with time the thickness of ice changes. How thickness of ice changes with time, that I will discuss. Before that, I request all of the viewers to subscribe my channel so that you can get information about my next all videos. Now you know this is the thermal conductivity of the heat and how thickness of ice changes with time. I am discussing. This is the water in the lake, and suppose the ice has been formed here. That is the ice of thickness X has been formed in very cold countries. So the temperature between the water and ice junction is 0 degree centigrade. Now the temperature is very cold in the country. Then the temperature is the minus theta degree centigrade is the atmospheric temperature. Suppose the X thickness of ice has been formed. Then you know conduction equation, tell me, that is, you know, dq dt is equal to k a d theta dx. So I can write down, so I can write down, that is d theta can be replaced by 0 minus theta, temperature difference. So I can write down dq dt is equal to k a is the area of cross section of the ice, k is the thermal conductivity, d theta means what? 0 minus theta by thickness of the ice formed is what? X. So I can write down, this is the scenario, this is the, suppose the water, that is the ice, the thickness of the ice is what? X. I consider a very small section, of ice, that is dx. I consider a very small section of ice dx has been formed. Let dx, thickness of ice formed, in dt second, and dm is the mass of ice formed. So I can write down, that is the dq dt is equal to what? K a theta by x. Now how to find dq? dq means what? You know, for ice formation the latent heat L is involved. I consider L is the latent heat. I consider L as the latent heat of ice. So dq is equal to what? dq is equal to dm into L. dm is what? Mass of the ice formed. dm is the mass of ice formed. So I can write down dq is equal to what? You know the formula, dm into L. That is the heat needed or heat released by the water. dm into L. So dm is equal to what? dm into L. Now dm is equal to what? Mass means what? Area of cross section of the ice is A. Thickness of the ice is what? dx. So A into dx. That is what? Volume of the ice formed. Volume into rho. Rho is what? Rho is the density of ice. A is the area of cross section of ice, and rho is the density. So I can write down dq is equal to what? dq is equal to a rho L into dx. So dq dt is equal to a rho L dx dt. That is, this is your equation number 1. This is your equation number 2. I think all of you clear, no problem. A is area of cross section, rho is the density, L is the latent rate, and dx dt. So ultimately we equate this 1 and 2. So I can write down from 1 and 2, you can write down that is a rho L dx dt. That is equal to what? K a theta by x. I think all of you clear. So from this equation I can write down that is a cancel out, x dx is equal to k theta by rho L into dt. Now you integrate this. Integrate means what? Suppose you go to the lake at night 10 in the very cold countries. What do you say? Fine. Suppose at time equal to 0, suppose starting time is at night 10, you find the thickness of ice is x1. You go to the same place at night 12. What do you find? Thickness of ice has been changed to x2. So with time, the thickness of ice is changing. So at time is equal to 0, thickness of ice is suppose x1. At time is equal to t, thickness of ice is x2. So if you integrate it, you can get x2 square by 2 minus x1 square by 2, that is k theta by rho L into time. If you start at the starting time, suppose no ice has been found, suppose. So if we write down, if x1 is equal to 0 and x2 is equal to suppose x, say, suppose starting time no ice, after some time ice has been formed. So from this equation you can find out that is what? That is x square by 2 is equal to k theta by rho L into time t. So x square is proportional to time t. So ice does not form linearly with time, but is a quadratic equation. X square proportional to t. So the relation is what? Parabolic. Time versus thickness of ice is what? That is a parabolic nature. So if suppose you are appearing for the NEET exam or JEE exam, what question you can expect? Suppose the correct relationship between the time and thickness. Suppose the question in NEET exam, that is the correct answer, thickness of ice x versus t relation. What is the correct base fitting? X square proportional to t. Second option, x proportional to t square. Third option, x proportional to root t. And number 4, none of all. So correct option is what? X square proportional to t. In that way, ice formation over lake and this varies with the time. I think all of you clear. I am stopping my class here. In my next lecture, I will give the radial heat flow. In my next lecture, radial heat flow. Before that, again I request you to subscribe my channel so that all of my video channels you can observe. Thank you.